everybody. This is a video to go through 4 different examples of doing factoring using the area model. The purpose of this video, as you can see up there, is to use an area model to factor trinomials with an a value of 1. I encourage you to grab your own piece of paper or notebook and pencil and do these along with me. You should also plan on pausing this video as often as necessary to try things on your own, or to catch up, or to just stop and think about the stage or the part you're on and make sure that all of this is feeling good. All right, so really quick, let's talk about the language. A trinomial looks like this. There are 4 examples. 1, 2, 3, 4. Each of those are trinomials because they have 3 terms. Tri means 3. So terms are these pieces separated by the plus signs. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And when we say an a value of 1, what we really mean there is the number in front of x squared is 1. And here you might be like, but wait, I don't see a 1. But remember, we always assume the number in front is a 1 if there isn't another number there. So these 4 examples are all examples where the number in front of x squared is a 1. Or if you don't see the 1, it's not 2 or 3 or 4 or anything like that. It's always just a plain old x squared in every one of these examples. And these are the first kinds of trinomials we're going to go and work with. Okay, so I'm looking at this first problem, x squared plus 7x plus 12. And if you haven't already, grab a piece of paper, pause the video, and make sure you can get all this written down. Once you've got it written down, we are going to start by drawing an area model. And the area model will always be a square or a rectangle. And what we are going to do is we're going to put the 3 parts of our trinomial into the box. And this, hopefully this isn't the first time you've seen this, so you've already noticed a couple patterns here. But if it is the first time, let me do you a quick reminder where ultimately we're going to put a number here, 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 and here. And in these 2 first positions, there's always going to be an x and an x. And the area model is just meant to remind us how things get multiplied together. So x times x is x squared. So we see the x squared in the trinomial goes in this box right there. Let me circle that for us. X squared of the trinomial always goes right there. Now the hard thing we're trying to do is we're trying to figure out what numbers are going to go here and here. So the sides are the factors of my final answer. And these 2 sides are always going to look like x plus or minus a number and x plus or minus a number. So the rest of this problem is to figure out what goes here and here. And these are the same things that are going to go here and here. And let me underline that. So the number here and here are going to be the same as the numbers here and here. Okay, so how are we going to figure those out? Well, this 12 is the result of these 2 unknown numbers being multiplied together. So this number times this number is going to be a total of 12. And let me put this in kind of a thought bubble over on this side. So those 2 numbers are going to multiply together to be a total of 12. And there are a lot of options. So we need to do something else to kind of narrow down the options. The 7x is not going to go in either one of these boxes. But the things that do go in these boxes are going to combine or add up to the total 7x. So let me put another thought bubble there, and let me underline or put a square around these. So the two things that we put in here are going to add up to a total of 7x. So then you have to start thinking to yourself, and this is more creative than a lot of what we do in math, because you can't just follow the steps and get the right answer. This you actually need to think for yourself, and you need to invent options, create options for yourself. So what are the options? Well, what kind of numbers multiply to 12? Can you make that list? We can do something like 1 times 12, 2 times 6, 3 times 4, and I think that's it. You could do more, but they'd just be like the same thing in a different order. And so we have to think, well, okay, are there different versions of this that also somehow like connect to adding to 7? Well, 1 plus 12 is 13, 2 plus 6 is 12, but 3 plus 4 is in fact 7. So maybe the things that go in these boxes have to do with 3 and 4, and they do. But it's not 3 and 4, it's 3x and 4x. So 3x and 4x. Just to be clear, the x comes from this x over here. This x, remember, is this side here, so this x comes from this x up here, which means the 3 must come from the side of the rectangle. So this 3x comes from the 3 over here being multiplied with the x over here. The 4x, the 4 will come from the 4 over here and the x over here. Same way the 12 comes from multiplying the 3 and the 4. Can you like trace your fingers? So you can take your fingers and just trace, right? The 3 and the 4, zoop, 3 times 4. The 3 and the x, zoop, 3 times x. The x and the 4, zoop, 4 times x. And the x squared is just zoop, x times x. So you have that like cross motion, right? They all line up in the right spot. And so once you have those numbers, the 3 and the 4, you did it. So I can put a plus 4 here, and I can put a plus 3 here. And that's it. Okay, so I want us to like recap the big ideas to get to our final answer of x plus 4 and x plus 3 for this first example. So let's do some recapping. So we started out with x squared plus 7x plus 12, right? And it's not maybe clear why it matters, but I do want you to focus on the fact that in this first example, it was a plus 7 and a plus 12. If you look at these other examples, you might notice that it's not, these other examples don't have the same pattern of plus and plus. So we're going to think about why that matters in a minute. So the question that we're asking ourselves for this problem ultimately was, what are two numbers that, and they had to do two things, right? So the first thing they had to do, two numbers that multiplied to 12, and two numbers that added to 7. And it's important to see where those came from, right? The 12 came from the 12 there, and the 7 came from the 7 there. So multiplied to 12, right? 12, 12, and added to 7, 7, 7, and then 3 plus 4 is that 7, right? So that was the question you were answering. The area model, these thought bubbles here are all to help us organize our answer to this question. The other thing that ends up being true in this example is that both numbers are positive, right? And so we think about this, right? Maybe made a list, maybe tried some things that did work, tried some things that didn't work. And we ultimately ended up with 3 and 4, 4 being those answers. So our final answer was not 3 and 4, right? Our final answer was x plus 3 and x plus 4. And do you see how I did it in a different order in this version and in this version? Both versions are fine. Both answers are correct. So that's it for this example. So now we got 3 more to do, and I'm going to speed up just a little bit now that we understand the basics of how it's going to get set up. So this next example, I'm going to start the same way. Make my area model. And now I'm going to fill in some things that I know are going to happen every time. I know that the x squared, because of the way we set up the area model, is always going to start there, and that these 2 outer pieces will always be an x and an x. I also know that the minus 18 is always going to go right here. So this one is x squared minus 3x minus 18. X squared minus 18. And then we can start thinking. So my minus 18 is going to come from 2 numbers being multiplied by each other to get to a minus 18. These 2 are going to combine, right? And I say combine, but we could also think of add to a total of negative 3x. So this is a bit different because now you need to think of things that multiply to negative 18. Well, if you multiply to negative 18, that means one number has to be positive and the other number has to be negative. So we're thinking of examples, so a thought bubble inside a thought bubble. We're thinking of examples of numbers that multiply to 18, but one is positive and one is negative. So I could do like, 1 times 18, but then either the 1 is negative or the 18 is negative. So negative 1 or negative 18. I could do 2 times 9, where 1 is negative, 1 is positive. I could do 3 times 6, where 1 is negative, 1 is positive. Are there any others? I don't think so. I think that's it. So then how do we get these to add up to negative 3? Well, if I do 3 plus 6, that's 9. But wait, it's not 3 and 6. Remember, 1 is negative, 1 is positive. So if I do, like, for example, and we'll do another thought bubble inside a thought bubble. So if I do negative 3 and then a positive 6, that would be a positive 3. But if I do positive 3 and negative 6, that would be a negative 3. Oh, isn't that the number we wanted? Haha, I think it is. So let me circle that. And also give you guys a hint. Notice this was a negative 3 and a positive 6, and the answer was a positive 3 where we wanted a negative 3. This is like close, right? This is like almost good enough. And to get to minus 3, I just switched my minus signs here. Keep that in mind for maybe our next example. So this tells me that positive 3 and negative 6 are numbers that will combine to negative 3. So I'm going to make this positive 3x and negative 6x. I'm going to put those in there. And these also tell me, the 3 and the negative 6 tell me what numbers to put out here. So this has to be a negative 6, and this has to be a positive 3. And then, right, if you don't believe me, let's like fact check this by doing some diagonaling. So 3 times negative 6, negative 18. 3 and x become 3x. X and negative 6 become negative 6x. X and x become x squared. And the things in this box combine to our original solution. So the outsides of this, so the outsides become my two factors, x plus 3 and x minus 6. And then let's do a quick thought bubble to think about what we were doing. So the original problem was x squared minus 3x minus 8. And let me circle, this was minus and minus, right? So what were the two questions, right? Two numbers that did what? And here I'm going to ask you to pause the video and see if you can think of the two questions. And I'll give you the beginning of each of these. So two numbers that multiply to something and that add to something. So fill this in, see if you can figure out what we're multiplying to and adding to in this problem, and then unpause the video and I'll tell you what I think we're doing. Okay, so we are looking for two numbers that multiplied to negative 18, right? 3 times negative 6 is negative 18, and that added to negative 3x, negative 3x. And maybe if you don't want to include the x, that's fine as well. Two numbers that multiplied to 18 and added to negative 3. In contrast to the previous problem, in our final answer, were both of these numbers positive? No. One is negative and one is positive. Can you tell how we would predict this in the future? It has to do with the multiplication. Remember how we started? If you want things to multiply to a negative 18, one is negative and one is positive. And in this example, they had to total negative 3, right? So when you look at this problem, normally you would say, like, which is the bigger number, 6 or 3? And we'd say, well, 6 is bigger than 3. So if we want the total to be a negative, then that means we need the 6 to carry that negative sign, to make sure that when we add them together, the bigger number is negative. So not only is one negative and one positive, but we can also say that the bigger number is negative. And I want to put bigger in quotes because technically negative numbers are tiny because they're negative, but I think you know what I mean. So then we say, we think, and we make a table and we make options and we get some wrong. And we finally figure out that those numbers are negative 6 and 3. And so our final answer is x minus 6 and x plus 3. Great. All right, 2 more to go. I'm going to speed up even more because I think you've seen 2 examples. And so let's get into this next one. If you need to pause the video to catch up or to spend some of your own time thinking, that sounds like a good idea. and then you can unpause the video when you're ready to keep going. So this is x squared plus 2x minus 35. I know there's going to be an x here and an x here, and this is going to be x squared. I know the minus 35 is going to go here, and I see another minus sign. So I know in my thinking, this is going to be some positive number times some negative number to get to negative 35. And then here, I know that I need to think of two things that add to a total of positive 2x. Well, negative 35 is actually a little easy because 35 is either 1 and 35, which aren't going to combine to be 2, or 5 and 7. So 5 and 7 combine to 12, right? But remember, if 1 is negative and 1 is positive, it's a slightly different question. So we can either do positive 5 plus negative 7, or we can do negative 5 plus 7. Which one of these would get me a total of positive 2? Well, if we want positive 2, then we need to go with this second option. The 7 is positive and the minus 5 is negative. So from this, I know I can fill in not just minus 5, but minus 5x. And not just 7, but 7x. And the minus 5s and the 7s are going to go on the outside here. Right? See, minus 5 and 7, negative 35. Minus 5 and x, minus 5x. X and 7, 7x. X and x, x squared. So then my final answer is going to be x plus 7, x minus 5. Ta-da! Okay, so what is the thought process behind this answer? Well, this problem was x squared plus 2x minus 35. So plus and minus. And what were the two numbers? So two numbers that, and here's where you would pause the video and see if you can fill this out for yourself. Two numbers that ultimately did what? Okay, welcome back. So these are two numbers that multiply to negative 35 and that add to positive 2. And we think to ourselves, well, since they had to multiply to negative 35, we know that one of the numbers is positive, but one is negative. And since they have to add to a positive 2 this time, we know that the bigger one is the positive one. And we thought to ourselves, and we figured out those answers were 7 and negative 5. And so then, let me just do like dashes up here because I'm running out of room. And so then our final answer was x plus 7 or x minus 5. And we can do it in the other order too. We could say x minus 5 and x plus 7, and it's the same thing. Shall we move on to the last one? Okay, if you need to pause and take a breather, that makes sense. Unpause the video when you're ready. And I'm just going to be copying down the area model for this last problem. All right, this problem is x squared plus 6x plus 8. Well, I know the x squared and the x's are going to go here and here. I know the 8 is going to go here. And here I see plus 8. So if this is positive 8, something times something has to be positive 8. That's different than these two, isn't it? And I know that somehow the total sum has to be something plus something has to be negative 6x. So what multiplies to 8 but will somehow let us add to a negative 6? This is unusual, but now we need to remember the other situation with negatives. You remember what it is? This is the situation where if you have one negative number and another negative number, now when you multiply two negatives together, you get a positive number back. So here, this positive 8 could come from negative 1 times negative 8. It could come from negative 2 times negative 4. Is that it? Yeah, I think that's it. Okay, so let's think. Negative 1 plus negative 8 is not going to get us to negative 6. Negative 2 plus negative 4, negative 2 and negative 4 do get us to negative 6. So that tells us, and are you noticing what I'm doing? It says negative 6x, but I'm just thinking about negative 6 for right now, because I know that the negative 2 I could put here, and then this becomes negative 2x, and the negative 4 I could put here, and this becomes negative 4x. And the negative 2x and the negative 4x become the negative 6x. Negative 2x. So I don't have a lot of room to write. Hopefully you guys can see that. So then I would write my final answer as x minus 2 and x minus 4. The minus 4 and the minus 4 go here. The negative 2 and the negative 2 go there. And that is the last one. So let's talk about the thought process behind this really quick, and then we'll call it a day. So thinking, this said, the original problem up here was x squared minus 6x plus 8. And so what was the question? Right. Pause the video and see if you can think of the question. Maybe use these as examples. Okay, you ready? So we want how many numbers? Two numbers that do two different things. One, they have to multiply to a total of 8, right? Negative 2 and negative 4, 8. And they had to add to negative 6. So multiply to 8, add to negative 6. And what can we say about these numbers? Well, since the multiplication had to be positive, but the sum, the adding, had to be negative, we knew that both numbers are negative. And let's see where we got that from. Here, right, remember the multiplying number was positive, but the adding number was negative. So both numbers are negative. And we thought about it, and we thought about it, and we realized that those numbers were negative 2 and negative 4. And we were able to write down our factors, x minus 2 and x minus 4. So I did a lot of writing for this problem, but before I stop, I just want to say, the more of these you do, the more you might start noticing you can do some of this in your head. And if you are noticing that, that is okay. The people who have done this a lot, and I'm talking about your fellow classmates, or not your classmates, but your fellow students at Skyline. I'm talking about sophomores, I'm talking about juniors, I'm talking about seniors. There are people who have done this enough that are doing almost all of it in their head. They can look at this first trinomial, x squared minus 6x plus 8, and for them, the very next thing they can write down is x minus 2 and x minus 4. You do not have to be at that point today. But if you start asking yourself, wait, is all of this writing really necessary? It is only necessary to help us think through all of these questions, right? Once you start getting these questions down, once you start getting good at answering these questions, thinking about those multiplying numbers and those adding numbers, you might start to skip some of these steps. That's probably not this week. It might be next week. It might not even be the end of the year. But just so you know, that is kind of the direction we're going. All right, this is a long enough video. Please feel free to watch it and rewatch it as much as you need. And I hope this was helpful. Take care of yourselves and take care of each other. Bye-bye.